Welcome everybody. The goal of this video is to show you how to deploy and test new feature on ezPlatform on its past system, Platform.sh. So what I'm gonna do here is go to my ezPlatform project that I've created on Platform.sh. A project is basically a set of containers that are needed to run your application. So for sure your application container, my ezPlatform one, but also all the services I need to my application for it to work. So my database, my Solar index, my Redis cache, for example, etc., etc. What I've deployed there is just the ezPlatform demo repository available on GitHub, and that's pretty much it. As we love simple things at Platform.sh, we've based all our deployment workflow on Git, so the only tool you need to know to deploy new code or an application to platform is only Git. As you know, in Git, the main branch is called master. So the master branch here will be our production environment. We can go and check the current content of this environment. We've got an auto-generated host name. I've got no custom domain name or certificates configured on this environment, but this could be done directly through the interface or the CLI tool. So we've got our ezPlatform demo project with all its content and all the code base related to it. The main good thing about Platform.sh is that we can create new test environment on the fly. So you can test new features, new bug fixes, etc., etc. So I'm gonna create two new environments. The first one will be called feature O. We'll just change the basic layout of our blog just right there. And the second one will be called Solar, because we'll integrate the Solar search engine in our project, so ezPlatform can fetch its content directly from Solar instead of MySQL. So, as you can see, I've just created two new environments. Those are children of the master one. This means they automatically inherits all the configuration, but also the data of the production environment, and that's really important. We rely on a layered file system that allows us to bootstrap new environments in less than 2 minutes without having to clone or duplicate all the production data to those environments. But you can access all of it. That means you don't need to run features or data tests to test your new code, but you will rely on the production data readily available, and every modification will be only available to the current environment, and for sure you won't be modifying production content on another environment. My home environment is ready, and I can access it through its new address, which is called the branch name, home, and project id.platform.sh. And as you can see here, we've got the exact same content. But this environment is a whole new isolated environment on different grid servers. So no matter what I'm doing to this environment, it can't impact in terms of performance or even code the main production branch. So I'm gonna begin developing on this environment. So this is just a quick edit to see how it works. Nothing complicated here. I'm just gonna switch the pictures and the content, so the pictures will be on the right. Okay, as everything is based on Git, my files are tracked, and Git is saying, okay, you've got modification in blogpass.html.twig. I'm gonna add this to the index and commit that. Oops, commits, change blog layout. The only thing I need to do now is to push to the platform remote my branch to my environment. For sure you can use GitHub, Bitbucket, or even your own GitLab repository. It's up to you to define your own workflow if you want your CI tool to push to platform, or if you want to do that directly from your computer. It's really up to you to choose. Whenever you push new commits to platform, our Git servers will analyze the content that has been changed, if it's just a code content or configuration content that has been modified, and we will recreate all the different containers we need. So in our case, we need to rebuild the app container because I've modified some Twig templates. Okay, the environment should be ready, so we're gonna head to it, and yes, all my pictures are now on the right of the content part. And for sure, if I refresh my production environment, nothing has changed and nothing has been impacted by the modification on the other environment. My solar environment has been ready for some time. So I'm gonna check out this environment. So this could also be done directly through Git with a git checkout and the name of the branch, but the platform CLI tool also includes some tests to check if the environment is up and working. So, alright. As you know, ezPlatform already shipped with the Solar bundle to connect to it, so the configuration is almost there. We just need to go to our Platform.sh configuration, which is the main configuration file for Platform.sh environments, and we'll need to add this service. So just let's take a minute to review the content of this file. First, we need to give a name to our application. This is mainly useful when you have multiple web containers, like for example an ezPlatform API, and on top of it a Node.js frontend, for example. So we need to be able to route requests based on the container's name. Each container needs to have its own runtime, so we can support PHP, Ruby, Python, Go, and even Java. And you need to specify which runtime you want to use. So in my case here, I'm using PHP version 7. We can run PHP 5.4 to PHP 7.1. And the most important part is what we call relationships. Relationships are the different services you need in order to run your application. So in my example, just right there, you can see that I've got a database key that is mapped to a MySQL instance. And I'm going to add a new search key that is mapped to my new Solar that will be created on the next deploy. We've got another extra configuration file called services.yaml. This is completely optional, but as ezPlatform needs to have a specific Solar configuration with schema.xml and solarconfig.xml, those are directly taken from the ezPlatform Solar bundle, I need to specify to my Solar service that it needs to update its configuration from this folder. But that's all. We've got two other important things in this configuration file. The first one is what we call mounts. As you know, your application needs to be able to write some different files, whether it be cache file, logs files, or user-generated content. But as we deploy all our containers in a read-only mode, you need to have those locations defined, so we can mount volumes on top of them and use persistence to be able to replicate this content on the different environments. The last part is what we call deterministic deployment. Whatever the source code you'll be pushing into your remote repository will apply some build and deploy step. In the build loop, we are able to write whatever we need in the container. So we'll fetch all the composer dependencies, remove the development controller, etc., etc., and we'll even dump all our assets through asset.tech. On the next phase, the deploy one, you'll be able to run any command against the different services. So for example, you can run your migration. In my case, if the project is not installed yet, I'm initializing ezPlatform :install. You can even remove some cache, etc., etc. It's really up to you. But the most important thing is that every developer will be using this deploy pipeline to deploy his project. So no matter their own tooling locally, they all be using the same tools to deploy, build, and test the application. That's really important. So my two files have been modified. Let's just check that. Alright, we're gonna add those to the index and commit add solar search underline. And exactly the same, we're gonna push that to the platform remote on the fsolar branch. As you know, ezPlatform is based on Symfony, and it takes all its different credentials to connect to the different services from the parameters.yaml. As we need to be able to inject those credentials into variables into the main application container, you need to update your project so it will be able to fetch those credentials. It's really simple. It's just a matter of reading an environment variables, getting the key you want that you have defined in your YAML file, and injecting in the service container of Symfony the different parameters we need. So in our case, the search engine and the Solar GSM, and that's all. Okay, so our app is redeploying and rebuilding everything it needs. So we're gonna refetch all the composer dependencies, everything, running the asset dump as you've just seen, and we're going to ship this to new grid servers. Those environments are once again completely isolated, so you can't mess with your production one if you're doing anything else. While it's redeploying, we're going to just take a look at the hierarchy between environments. Whenever you create a new environment, it automatically inherits all the configuration from its parent. So in my case, Home and Solar are directly depending on the production one, master, so they can retrieve all the configuration from master. This means, like, for example, you're using PayPal to do and process some payments in your application, so you need to have your production key available for the production environments. You can define as many environment variables as you need. So in my case, I've just created PayPal_key with the value my production key. But what's really important is that every other environment than master should not use this my production key value. So once again, you can override this value. Like for example, on this staging environment, I've just overridden the PayPal key with the value my sandbox key. The good thing about this is that every environment underneath staging will have this overridden value. So you're 100% sure that none of your developers will be using the production key instead of the sandbox key. And that's exactly the same for user management. Let's say you're working with external agencies, freelancers, or even interns, and you want to be able to give them access to a specific environment, or a sprint in my case. I've just added Guillaume Demo as a contributor to the sprint-free environment. That means Guillaume is able to log in on his own account and access a project, but only access a different environment that you've specified before that. So no matter what Guillaume is doing, he can push to the master branch or even read content from the master branch, and he is not able to see the PayPal production key. So that's really good security thing, and clearly that can also be automated through your project management tool. Let's take an example. Whenever you create a new issue in Jira, you can bootstrap the environment and give access to the environment to the ticket assignee, for example. Okay, my Solar branch is deployed. We're going to check this environment. As you can see, we've got our layout and basic content, but we're missing the project and the blog article. And that's completely normal, because in our case, what we have just done is create the new Solar index, the new Solar service, sorry, and we have connected ezPlatform to this Solar instance, but the Solar index is not created yet. In order to do that, we need to connect through SSH to the environment. This can be done easily through the CLI tool. You just need to type platform.sh, and we check the current branch you're in, and we connect you to the matching environment on platform. And the only command you need to create this index is the ezPlatform :reindex file. This is going to connect ezPlatform to Solar and reindexing all content available currently on ezPlatform MySQL database. We're just going to wait for 2 seconds for it to complete, and right now, when we refresh our Solar environment, we got all the same content as a production one, except all the content is fetched directly from Solar instead of MySQL. Okay, we've got our 2 new features completed. You can send the address for your internal or external customer for them to review. And once it's validated, you've got 2 different choices. You can merge directly the branch through the interface, or you can do a basic git merge. As a tech lead, I'm sure you'll prefer to do that way. So I'm going to merge fsolar and fo. Yeah, the message yes. Okay, and I'm going to push that to the platform remote on the master branch. And once again, we're going to analyze what have changed and we're going to redeploy the content. In my case, I could also have added the Solar reindex command directly into my YAML files, so it can be fully automated when I deploy. I just run that manually. In terms of feature, we also have two very interesting features. You can create snapshot of the whole infrastructure on the fly, so the code base, the data, and the in-state memory. So we can have a whole working snapshot of your project in case if something fails. For example, you just pushed a fatal error or something like this, you can revert to a snapshot for 14 days. Another great feature is that you can also sync your parent code and data files to your current environment. That means, for example, your marketing team has updated the content of your different blog articles and everything, and you want to test that in your environment. You can resync the content so it will retake all the data layers, so the MySQL database, the Solar index, etc., and directly resync that into your own environment so you can test with the last update of the content. Okay, my master branch is deployed. Once again, I'll be missing my content and articles, so I'm going to do the exact same thing. Platform.sh. I'm connected to the master environment in just 1 second, and I can reindex my content. So what I've just done here is create two new environments, test the two features in a completely isolated way, review them, and next push that into my production service. Okay, just take a little time for Solar to index, but yeah, you know the drill. So that's pretty much it for that demo, and I hope you'll better understand now the concept of ezPlatform on Platform.sh. Thank you.